One of the most common tasks in JavaScript is to build, mutate, and extract data from objects and arrays. ES 2015 makes this process very compact with destructuring. In this lesson, we will start with the introduction of the object property shorthand notation. In the second section, we will build on the shorthand notation and learn destructuring by example. You will find out what the return value of a destructuring assignment is. This will make it possible for you to understand what happens when we concatenate multiple destructuring assignments. In the fourth section, deeper destructuring examples will enhance your knowledge about destructuring. You will also learn that destructuring assignments work in the same way as pattern matching and destructuring function arguments. We will conclude this lesson with an important disclaimer about destructuring, a bug alert that you have to pay attention to in order to write robust code. This is a simple ES5 code creating a file object with a file name, an extension, and a language. Notice that we had to write language, extension, and file name twice. This is not good. It pays off to be lazy and write more compact code. ES6 allows that with the object property shorthand notation. The notation itself looks like this. After console logging file, you can see that the two solutions are equivalent. The shorthand notation is optional, and you can even mix the shorthand notation with the regular notation. Obviously, if one of the attribute values are missing, the shorthand notation will fail just like the regular notation does. Let's start with a simple object with these four properties. I will now write a surprising line of code. Fasten your seatbelts. What does this assignment mean? Well, this is a declaration of two new variables, email and next lesson. The email and next lesson variables become top-level variables. I will now illustrate how JavaScript evaluates this destructuring assignment. We substitute user with the corresponding object. Let's replace the shorthand notation with the regular notation. Let's also hide the irrelevant field for a moment on the right, as they don't matter from the perspective of this destructuring assignment. These values are simply thrown away. Notice the common intersection in the structure of the left-hand side and the right-hand side. We have variables on the left and values on the right. This assignment is a let declaration declaring the email and next lesson variables. This declaration is transformed to two declarations, individually declaring the new values. The only catch in destructuring is that these two declarations are simultaneous. This is why we can use the same values both on the left and on the right. In this example, we will simultaneously increment the values of variable a by 1, throw away the original value of b, and equate b with a plus 1. Notice that I didn't place let in front of the destructuring statement, as we didn't declare new variables, we just assigned new values to a and b. The value of a is 2 is straightforward. What do you think about the value of b? Make an educated guess and pause this video if you want to. Welcome back. The value of b is 2 as execution of the two assignments in the destructuring assignment is simultaneous. We can simulate this simultaneous execution with temporary variables. Reusing this temporary variable in the last two assignments means that the order of these lines doesn't matter. We could even swap these two assignments without changing the result. Let's start this section with a riddle. Determine the value of name after this assignment is executed. As a side note, decide if the assignment throws a JavaScript error or not. Pause the video and place your bets now. Welcome back. Surprisingly, the assignment was made, no errors were thrown, and Ashley made it from the right to left, even though she disappeared in the middle. Well, a person disappeared and magically reappeared, but this is still not a Houdini trick. This example is a direct consequence of the return value of destructuring. The return value of email, next lesson equals user is the right hand side of the assignment, which is user. Now you understand why Ashley made it to the left. In practice, we hardly ever use multiple destructuring assignments. In a very unlikely scenario, we may want to create multiple references to a data structure and the field inside it, but there is absolutely no benefit in placing these assignments on the same line. It is possible to destructure objects and arrays in any depth. Default values can also be used. Objects or arrays that don't exist on the right become assigned to undefined on the left. In this example, we will destructure the contents of the lesson scene array. 1st to 5th receive their values. 6th is undefined on the right. This equation sign is nothing else but a default value. This value is assigned to 6th if its original value is undefined. Recall default function argument values, you can see the exact same process here. 7th becomes undefined in the absence of a default value. We have one more declaration. 8th becomes the value of next lesson in the original object. Destructuring can happen on any level. We dig in the structure of our arrays and objects and equate the variables on the left-hand side with the values on the right. You might have detected some foreshadowing in the previous section with the default values in destructuring. If there are default values in a destructuring assignment, we can see a similar process as in case of a function call. You might have even raised the question, is it possible that function calls are also destructured? The answer to this question is yes. Your only task is to determine the direction of the destructuring assignment. Think about it for a moment. If you need a hint, think about where we need the results of destructuring. Inside the function body or in the function call? The ultimate hint is, where do we place the default argument values? In the argument list of the function or in the argument list of the call? Exactly. Destructuring only makes sense if the function arguments are left values and the values in the call are right values in the destructuring assignments. You will learn practical use cases for destructuring in function arguments in exercises 5 and 6. We will conclude this lesson with a warning on potential bugs related to destructuring. Software developers tend to make mistakes. Don't overuse destructuring, always keep your code simple and readable. Continuing our first example, suppose you make a typo and write name instead of name. The typo silently assigns the value undefined to name, potentially causing trouble. Always pay attention to fine-tuning your debugging skills. My second warning is the following. In an L equals R destructuring expression, R cannot be null or undefined, otherwise a type error is thrown. This warning also holds recursively, as you may get into trouble trying to access a property of undefined. We have learned enough theory now for 6 exercises. Once you are done solving them, I will guide you through the reference solutions.